What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about system of nonlinear equations. So the word system just means more than one equation. So it's not any different than what we've done before. System just means more than one equation. If I already said that, awesome. If so, then I just repeat it. But anyways, if you have two unknowns like x, y, then you would need two equations to solve that. If you have three unknowns like x, comma, y, comma, z, then you'll need three equations to solve that particular system of equations. So this is going to be the same idea, except one or both equation is going to be nonlinear, meaning it's not going to be a line. All right. So I guess, and then wherever they cross would be your solution. So we're trying to figure out what the x or the y value of where they might cross. So let's go ahead and start with an example. So for example, let's start with y squared is equal to x squared minus 64. And the second equation would be 3y is equal to x minus 8, okay? So we're still gonna utilize the two methods that we've learned, which is elimination and substitution, okay? You're gonna have to kind of look at it and go, okay, what would be easier for me? What can I actually see? And sometimes you might have to kind of go trial and error with it as well. So you might choose one method, start doing it and go, ooh, this looks really ugly. Maybe let me try the other method, okay? And as you do more and more, you'll get used to it and you'll go, got it. I can make this work. So the first thing I see is that elimination seems to be much more difficult for me because the top equation is x squared and y squared, while the bottom equation is just x and y. So, but if I did substitution, I could take the second equation and solve for x. So if I solve for x, I'll have to add 8 to the other side. So I'm going to have x is equal to 3y plus 8. Okay? So now I'm going to take this and substitute it into the first equation. All right? And what am I going to get? Let's go and bring this right over here. All right? So when I substitute that in, I'm going to have a y squared is equal to 3y plus 8 squared minus 64. All right, so let's go ahead and get solve for y here. So now all the x's are gone, it's just y's left. All right, so what am I going to have? So I do have to remember that I do need to either FOIL this or double distribute this, right? Because I'll write down the 3y plus 8 twice and FOIL. So I'm going to get a y squared is equal to 9y squared plus 24y plus 24y plus 64 minus 64, okay? So how about if I even put it this way? This part right here is what I actually got from that FOIL so that you guys can see what was red and now it is red again. All right, now I'm going to try to combine like terms. So I'm going to have y squared is equal to 9y squared plus 48y. While the 64s kind of cancel each other out, I see a square and an equal sign, which has me thinking about quadratics. So that means I want to get everything on one side and then a 0 side. So I'm going to subtract the y squared to both sides. So I'm going to have 0 is equal to 8y squared plus 48y. I got to factor the right side. So I have 0 is equal to, my GCF is 8y. And I'll have left a y plus 6. All right. So now I'm going to take this work here and I'm going to go ahead and shoot it up this way. So what I have now is I'll rewrite this. So what I do is take each one each factor and set it equal to 0. Let me draw a real line here. There we go. So now I have a y is equal to 0, because if I divide by 8, I got y equals 0, and then I have y equals -6, right? So I got two y values here. In fact, what I'm going to do is I'm going to change the colors of these here. Let's make that green, okay? So what I want to now do is kind of plug in the y equals 0 into both equations and see what I get, and what will satisfy, what x value will satisfy both equations, all right? Because this part right here is telling me that the y equals 0 is going to satisfy both equations, and the y equals -6 is going to satisfy both equations. So the question is, what is the x value that would also satisfy both equations, all right? So right here, what I'm going to do, I'm going to take the y equals 0 and bring it down here. And then I'm going to take this y equals 6 over here. All right, so give it some space there. All right, so I'm going to put in y into both equations. So now I'm going to have a 0 squared is equal to, actually, let me do this. 0 squared is equal to x squared minus 64. So I have 0 is equal to x squared minus 64. Now you have two ways of solving for this, right? You can either use a square root property, which means that I'm going to add 64 to the other side, take the square root of both sides. However, don't forget that you have to put the plus and minus when you're taking the square root. The other way is to say, okay, I'm going to stay with factoring. I'm going to have x minus 8 and x plus 8. I'll set each factor equal to 0. So then I have x equals 8 and x equals -8. Okay? So I got to look at those two and say, okay, let me plug it into the other equation. And the other equation says it'll be 3 times 0 is equal to x minus 8. So I have 0 is equal to x minus 8. So therefore x is also equal to 8. Okay? So that tells me what I want to know here, and we'll stay with the blue, that when x is equal to 8, it will satisfy both equations, okay? Where here, the y is telling me that y equals 0 will satisfy both equations. So therefore, the point that is going to satisfy both equations would be 8, 0, okay? So that's one of my points. Now, if these two both matched, then I'll have 2 points here, right? The 8, 0 and the -8, 0. But only one of them stayed in common. That means that x equals -8 wouldn't satisfy the second equation that I wrote here, okay? All right, so let's go ahead and go over here with the x equals -6. All right, so let's go ahead and put that in there. So what I have here is I'll have -6 squared, right, is equal to x squared minus 64. So I'll have a 36 is equal to x squared minus 64. So same thing, two ways. I can either add the 64 over to the left, and I'll have 100 is equal to x squared and take the square root of both sides, which I'll get the plus and minus, or move the 36 to the right, and I'll get 0 is equal to x squared minus 100. again, is the difference of two squares. So I have x minus 10 and x plus 10 equals 0. So therefore, I have x equals 10 and x equals negative 10. All right, so now let's plug it into the second equation. All right, with the second equation, we have, let me see here, 3 times the negative 6, right, is equal to x minus 8. So same thing, I'm going to have a negative 18 is equal to x minus 8. Add the 8 to the other side, so I have x equals negative 10. Okay, so with that is the case, let me see here, let's use a pink. So I got x equals negative 10. Actually, let me make sure that comes out nice. I got x equals negative 10, which matches that one, but not the x equals 10. And then if I come back here, I have the y equals negative 6. So therefore, this point here would be negative 10 comma negative 6 would be my other point. Again, notice that the x's doesn't match, right, for both of them. So that's why we can only use one of them, but not both of them. All right, same idea as here on this side, except the only thing I'm going to change is the color of this right here over to red. Only reason is because the second equation was the red equation, okay? So that's why I did that. All right, so that would be my answer right there. So I would say, so these 2 points would be 8, 0, and negative 10, negative 6. There we go. All right. So let's try a second example. And the second example is going to show you kind of where things kind of match up. All right. So second example, let's see here. We have 3x squared plus 5y squared is equal to 32. And I have a 2x squared minus 3y squared is equal to 15, okay? So here I see x squared and y squared. So what I'm gonna do is go ahead and say, okay, I'm gonna, let me see here, I'm gonna go ahead and do elimination, okay? So what I'm gonna do is I'm gonna multiply the top. Let me see here, since the y squared is already positive negative, I'm going to just go ahead and get rid of the y squared. So I'm going to multiply the top by 3, so that I'll have a 15y squared, okay? While I'm going to multiply the bottom by a 5, so that 5 times negative 3 would give me a negative 15y squared, which then the y squared would eliminate. So let's take a look at what this looks like. So over here, I have 9x squared plus 15y squared is equal to 96. And the bottom one, let's see what that looks like. That's going to look like 10x squared minus 15y squared is equal to 75. Okay, so now let's go ahead and add these two together. Let's see what we get. We're going to get a 19x squared is going to equal to 1, carry the 1, so 17,171. So therefore, and then divide by 19, so x squared is going to equal to 9. So I'm going to take the square root of both sides. All right, so I'm going to go ahead and show you here with the square root property. So when I take the square root of both sides, I have to add the plus and minus in front. So that means I have x is equal to plus and minus 3. Okay, So with a plus and minus 3, that means I have two things here, right? I have, let me bring that over here. I have x is equal to positive 3 and x is equal to negative 3. So now I'm going to take those two x's. So x being positive 3 and negative 3 will satisfy both equations. All right. So now I got to figure out what about the y's. So I'm going to do exactly that again. So let me change these colors again. You know what? Let's go ahead and stick with the same colors here. Let's call this one green, and let's make this one blue. All right. So that it has some contrast with the red and the black. All right. So let's plug in 3 into the first equation. So I'm going to go this route here, bring this down this way. All right, and if I plug it in, what do I get? I'm going to get, I'm going to get 3 times 3 squared plus 5y squared is equal to 32. Is that the first equation? Yep, okay. So now what do I have? I have a 3 times 9 plus 5y squared is equal to 32. So I got 27 plus 5y squared is equal to 32. So now I have 5y squared is equal to 5, because if I subtract 27 from 32, I get 5. So y squared is equal to 1. Take the square root of both sides, but don't forget the plus and minus. So I have y is equal to 1 and y is equal to negative 1. Okay, so I got two answers here. All right, 1x, 2 y's. Now let's see if the same thing happens with the second equation. All right, so that one's in red. All right, so now I'm going to do the second equation, which says 2 times 3 squared minus 3y squared, and that's equal to 15. Is that the second equation? Let's make sure. Awesome, it is. Okay, so now what do I have? I got 2 times 9 minus 3y squared is equal to 15. All right, and the reason why it's not, you do the 9 first and not the 2 times 3 first is because order operation says exponents before you multiply or divide, right? So now I have 18 minus 3y squared is equal to 15. Wow, that's a really big 5, a fat 5. Okay, there we go. So now I got negative 3y squared is equal to negative 3. So y squared is equal to 1. So same thing, I get y is equal to plus and minus 1. So I do have y equals 1 and y equals negative 1. So if you notice, what do you just notice here? Is that the y equals 1 matches up, the y equals negative 1 matches up. So that means I actually have two answers here, right? When x is equal to 3, my y could be 1 or negative 1. So that tells me I actually have 2 points here. I have 3, 1. Oops. And we have 3, negative 1. Okay? So 3, 1 will satisfy both equations. 3, negative 1 will also satisfy both equations. If you don't believe me, try it out. It will work. Okay? So let's now talk about x equals negative 3. Oops. Let's actually draw a straight line. Okay? So let's bring it over here. First equation is going to be 3 times negative 3 squared plus 5y squared is equal to 32. So look at this. I'm still going to get a 3 times 9 plus 5y squared is equal to 32. 27 plus 5y squared is equal to 32. 5y squared is equal to 5, and y squared is equal to 1, which means, before I do that, let me make a better equal sign here. So therefore, y is going to equal plus or minus 1, which means y is equal to 1, and y is also going to equal to negative 1, okay? So the reason why I kind of flew through that is because if you look on the green equation, the blue equation, they're exactly the same steps, okay? So let's take a look at if we put that negative 3 into the second equation, okay? So if I plug into the second equation, let's see what happens. So I got 2 times negative 3 squared minus 3y squared is equal to 15. I have a 2 times 9. Let me write a better 9 here. Not squared, just 9. Minus 3y squared is equal to 15. I have 18 minus 3y squared equals 15. Negative 3y squared is equal to negative 3. So y squared is equal to 1. Same thing, if I take the square root of both sides, please don't forget that you need the plus and minus. So I got y equals 1 and y equals negative 1. So with that being said, let's choose something nice here. I'm just going to go with the purple and see how that comes out. Yeah, purple. All right. So notice how between the first and second equation, I still get y equals 1. I get the y equals negative 1, while I have x is equal to negative 3. So same thing. So this is agreeing with each other. So now that means I have also 2 solutions on this end as well. So that is going to be a negative 3 comma 1 and negative 3 comma negative 1. So all 4 of these would be solutions. So my solution is going to be 3 comma 1, 3 comma negative 1, negative 3 comma 1, and negative 3 comma negative 1. Okay. Now, again, this is going to lead you exactly where it needs to lead you in terms of how many solutions there are. Because if you notice, let's go back to the first problem here. Okay. If you notice that when we plug it into one equation, we got 2 answers, but when we plug it into the second equation, we only got 1. So it's the one in common that we want to use. So that's why this has only x equals 8 while y equals 0. So that's why 8, 0. Same thing with when we put the y in here, right? When we put the y in here, same thing happened. When y is equal to negative 6, I got 2 answers here on the first equation, but only 1 on the second. So that means the x equals negative 10 is the only one that would satisfy both. And if I use the x equals 10, it would not satisfy the second equation. So that's why we are leaving it out and keeping it rejected. So that's the reason why I have the 2 answers here, okay? So hopefully this helps you of why I have 2 answers for that first one. However, I got 4 answers for the second one. So these are the 4 points where these 2 objects or graphs would meet each other. All right, if you have any questions, let me know. Talk to you later.